Welcome to this e-learning module on Gas Handling Safety System at Tata Steel. Select a language to begin.
I am safety professional Ajay Kumar, and today I shall tell you about some important details that you should remember and follow while dealing with various gases at Tata Steel for your safety and safety of people near you.
Before we begin, let me quickly show you some important features of this module. You can pause or play the module at any time by clicking this icon. If you wish to view the list of various sections, you click the menu button here. You can also move back and forward with the help of these buttons. You can go to the home screen with the help of the home button. Quite simple, isn't it? Now, click Next to continue or replay to go through these features once again. It describes the recommended basic requirement for working on gas lines. It describes the precautions to be taken and safety appliances available. This standard is applicable to all locations of Tata Steel Limited in India. All working departments and contractors are responsible for implementation of this standard. Some of the hazards associated with handling gas lines and cylinders are gas exposure, fire and burns, explosions leading to loss of equipment and fatality, and falling from height. On December 2008, 2 contractors and 1 company employee were doing scheduled operation or maintenance job at BF Gas Holder. They were draining water and emulsion from oil collecting tank 5. While doing this operation, there was sudden release of blast furnace gas from the U-seal connected to gas holder lute and connecting tank number 5. The 3 persons were exposed to gas and were sent to TMH emergency along with first aid doctor in the company ambulance. A contractor employee was declared dead. A company employee was admitted to ICU and later transferred to CCU. A contractor employee was released immediately. That was such a tragic accident. Was there no way to avert it?
The incident could have been averted if all the steps of gas handling safety were followed diligently.
What are these steps? Take a look. The important steps to be followed for gas safety are: know the areas where a gas is in use and be alert while working in these areas. Keep a watch on the gas using a gas detector. The toxic gas may or may not have their own smell. However, some smell may be observed due to the presence of impurities. So, do not ignore any abnormal smell and test immediately with gas detector. Some of the common symptoms of gas exposure are heaviness of head, headache, dizziness, nausea, dimness of vision, loss of strength, unconsciousness, or even death. Any sudden physical discomfort should not be ignored. Immediately come out from the working place to a clean, open, comfortable atmosphere. Breathe oxygen and take medical help. Do not work on an empty stomach under sick conditions and intoxicating state in a gas hazardous area. Do not take rest or sleep in the area where a gas is being handled through pipes or other means or gas line job being done. Do not take risk if there is gas leakage. Report the leakage to concerned authority and gas safety department. Before working in gas hazard area, test the area for presence of gas and also take written permission for working in gas area. Do not operate or handle the gas valve or gas system without full awareness of the system layout and the job to be done. If you are involved in gas-related activity handling, then expect the unexpected and be prepared for any emergency or disaster. You should be equipped with emergency or gas safety equipment.
It is now time for a quick check.
Correct. Correct.
While I was going through the plant, I noticed various gas pipelines with different colors. What do these colors indicate? That is a good observation. The color on the pipeline indicates the type of gas it holds.
Click each gas type on the screen to take a look at the respective color code. Click Next to continue. Let us now take a look at gas concentration in the atmosphere and its effect on human body. An area with carbon monoxide concentration of 50 ppm has a safe working limit of 8 hours. At 400 ppm, short-term exposure limit is 15 minutes only. At 1200 ppm, there is an immediate danger to life and health. Correct. For ammonia, TLV equals 25 ppm, STEL equals 35 ppm, and IDLH equals 300 ppm.
Gases are either stored in cylinders or transported through pipelines. It is very important to follow proper job planning while working on gas pipelines.
Click each pipe on the screen to learn about proper job planning for working on gas line. Written gas clearance on form number EHSMSM/works/446/4001 should be received. Ensure general and gas safety training has been given. Clearance for permit to work in form number EHSMSM/works/446/4007. Use only non-ferrous tools for hammering, chiseling, and replacing nuts or bolts. Barricade the area and display Men at Work board. Click Next to continue. These points are so insightful. Is shutting the valve before commencing work sufficient, or are there any other precautions to be taken?
Good question. There is a clearly laid down process for isolation of gas line which needs to be followed before commencing work on any gas pipeline. Take a look.
For isolation of gas line, close the gas incoming and outlet line valve. Do water sealing in incoming line and outlet line. For continuous working in gas line having duration less than 24 hours, depute men at all incoming lines and all outlet lines to watch the inactness of the water seals. For the job having duration more than the outlet line. For continuous working in gas line having duration less than 24 hours, depute men at all incoming lines and all outlet lines to watch the inactness of the water seals. For the job having duration more than 24 hours, do blanking. Necessary nitrogen purging of gas line to be done before doing blanking. Put lock in drain valve.
It is now time for a quick check.
Correct.
Since we use many gases, how is it possible to know if there is a gas leak? At Tata Steel, we use some of the latest equipment for detecting gases.
The gas detectors widely used in TSL works for detection of carbon monoxide, oxygen, ammonia, hydrogen sulfide, and multiple other gases are of Draeger, BW, MSA, Oldham, and FLIR camera.
What are the various types of gas safety equipment and how they are different from each other? There are a wide range of gas safety equipment to address different types of requirements.
Some of the gas safety equipment used at Tata Steel are airline respirator, life oxygen pack, BG4 or SCBA, ELBA, and oxygen concentrator. Click each title on the screen to learn about it. Fresh compressed air supply is required at a pressure of 3 kilograms per square centimeter to operate the airline respirator, and it works so long you feel comfortable. Fresh compressed air supply is required at a pressure of 3 kilograms per square centimeter to operate the airline respirator, and it works so long you feel comfortable. Life oxygen pack. Life oxygen pack is used for supporting to breathe in oxygen in case of gas exposure or breathing problem. Full cylinder can be used for 90 minutes. SCBA or self-contained breathing apparatus is a device worn to provide breathable air in an immediately dangerous to life or health atmosphere. The term self-contained means that the breathing set is not dependent on a remote supply like a long hose. ELBA or emergency life breathing apparatus uses a compressed air gas mask. If the air pressure is 200 kilograms per centimeter square, it can be used safely for 10 minutes. Oxygen concentrator generates oxygen from the atmospheric air and is electrically operated.
It is now time for a quick check.
Correct. Correct.
Are there any specific rules for storing and handling gas cylinders too? Yes, there are very specific rules.
Let us now learn about some basic requirement for gas cylinder storage. The gas cylinder storage shall have designated place in isolated area, roof to protect from direct sunlight, adequate ventilation in storage area, warning signs, no smoking caution, and displayed safety instructions. All gas cylinders shall be capped when not in use, and all the gas cylinders shall be kept in upright position, secured to prevent accident fall.
Not just a cylinder, there are specific rules to be followed for the storage areas designated for storing gas cylinders also.
The storage area of gas cylinders should be away from exits and egress routes, damp area, salt and corrosive chemicals, heat, fumes, inflammable chemicals, fuel storage area, source of combustion, open flames, and steam pipes.
All gas storage areas have clearly placed signage indicating the do's and don'ts.
The commonly used signage associated with storage of gas cylinders are: gas cylinder storage area, gas cylinders full, empty cylinder storage area, keep all cylinders upright and secured, no smoking, cylinder storage area, and no admittance to unauthorized persons.
How do we know if a cylinder is safe to be used or it is very old and needs to be discarded? You can do this with the help of the permanent identification number.
Every gas cylinder is clearly and permanently marked for identification. The marking are done on the shoulder or base of the cylinders. In some cases, the markings are found on the valve protecting ring. These markings include the chemical formula and number of the gas it contains, charging pressure, water capacity, weight, cylinder's serial number, test pressure of shell, manufacturer's stamp, test due date, etc.
Is there any particular criteria for the color classification of a gas cylinder? Yes, there are two specific criteria.
Color classification of gas cylinders is done either by hazard property or by specific gas. When classified by hazard property, bright green indicates inert gas and red indicates flammable gas. When classified by specific gas, maroon indicates acetylene, white indicates oxygen, dark green indicates argon, black indicates nitrogen, gray indicates carbon dioxide, and brown indicates helium. Incorrect. Incorrect. Correct. 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 Click Next to continue.
You should be aware of the rules and adhere to them while handling and using gas cylinders, as even a small mistake can be fatal.
Let us now take a look at some important do's and don'ts for handling gas cylinders. Always provide suitable cradles to hold the cylinders. Use red hose for acetylene and other fuel gases, black or green hose for oxygen. Never interchange the hoses. Nozzle tips to be kept clean to prevent backfire. Use hoses of equal length. Close valves when a system is not in use. Use pressure relief valves in downstream lines to prevent high pressure buildup. Use only approved valves, regulators, manifold, piping, flashback arresters, etc. Ensure that correct pressure gauges on regulators. Conduct periodic maintenance for valves or regulators. Perform visual inspection before usage. Carry out repair works of valves or regulators by qualified persons only. Display the license number if the number of LPG cylinders stored is more than 5 or exceeds 100 kilograms at a time. Keep in upright position with secured and capped when not in use. Protect cylinders from striking, falling objects, corrosion or damage from public tampering, etc. Damaged or leaking cylinders must be reported immediately for proper disposal. Do not use cylinders as rollers or jacks. Sliding, dropping of cylinders are strictly prohibited. Cylinders shall not be picked up by the cap. Magnets shall not be used for lifting cylinders. Do not use welded, leaking, defective and corroded containers. Do not use chain slings for lifting cylinders. Only fiber slings should be used. Do not lay gas cylinders on wet soil. Do not lubricate cylinders' valve threads. Do not coil the hoses around regulator or cylinder. Keep away flammable gases from ignition sources. Ensure that fire extinguishers are available for fire emergencies. Flames shall not be used for detecting leaks. A leak detection solution shall be used for leak detection. Spark-proof tools to be used for flammable gas cylinders. Access doors to areas which use or store flammable gases shall be posted "No open flames." Do not use oil or lubricant in any apparatus where oxygen is used.
It is now time for a quick check.
Correct. Correct.
While adequate care needs to be taken for handling and using gas cylinders, it is also important to be prepared and equipped to handle any emergency that may arise while handling or using gas cylinders.
Prior to working with gas cylinders, users must be familiar with the nature of the operation of equipment, safe operating procedures, necessary safety precautions, chemical, physical and hazardous properties of gas like its toxicity, corrosivity and flammability, possible accident scenarios and post-accident employee responses, etc. As a contingency plan, information about building evacuation routes, emergency telephone numbers, chemical containment procedures, and fire extinguisher usage, etc. should be posted at the site. Click Next to continue.
What should we do if we detect a leak? There are some very simple but important steps to be followed.
For minor gas leakage, use a flammable gas detector or soap water solution to verify it and never use any flame. On detection, Move the cylinder to an isolated, well-ventilated place and put plastic bag, rubber shroud or similar device over the top and tape it if possible. For major leakage, activate fire alarms. Evacuate the area. Call fire brigade and report the incident. Provide emergency response team with details of the problem upon their arrival.
What should we do in case of an untoward incident occurring due to a gas leak? You should not panic and follow the clearly laid down procedure. Take a look.
In case of an incident, assist and administer immediate first aid by washing under a safety shower in case of burning cloth or chemical exposure, removing contaminated clothing, irrigating the eyes at eye wash, administering artificial respiration, also known as CPR. Notify personnel in adjacent areas of any potential hazards by activating building or area alarms. Move injured personnel only if it is necessary to prevent further harm.
One of the major use of gases at Tata Steel is for welding.
Welding is defined as the fusion of two pieces of metal by heat or by fusion or by both. During electrical arc welding, the arc is generated between an electrode and the workpiece. Temperature attained by welding arc is approximately 4000 degrees centigrade. At this temperature, the workpieces melt and fuse together.
Welding is a hazardous process and requires special equipment, training and attention.
Let us now learn about some of the hazards associated with welding and precautions to be taken to avoid them. Shocks can occur due to defective holders or welding returns. Lowered body resistance caused by wet conditions or crossing of welding cable and power cable. To avoid shocks, the electrode holder should be fully insulated. Live portions should not be touched. Machine grounding to be ensured. Hot electrode holder shall not be dipped in water. Cable connected with the holder shall have adequate current carrying capacity. Repaired cable shall not be used. Click Next to continue.
What are the common hazards associated with welding? Burn injuries, eye injuries, air pollution, fire and explosion are some of the potential hazards associated with welding. Let us learn about each of these in detail.
Burn injuries can occur due to hot spatters, touching hot job or bare parts of holders, flash from short circuit or exposed cable and excessive heat. Some of the precautions to be taken to avoid burn injuries are to use welder hand gloves, flame-proof aprons made of leather or other suitable material, welding shield and wearing tight or protective clothes. UV rays from welding arc can damage interior layer of the eye and retina. A common eye disease is welder's conjunctivitis. Never see the arc directly. Use welder's helmet or shield with shade. Helper to wear plain goggles with shatterproof lens with thickness greater than 3 mm. Airborne contaminants found during welding are chromium, manganese, molybdenum, carbon monoxide, fluorides. Some of the precautions to be taken to prevent air pollution are: contaminated air exhausted should be discharged into open air. General ventilation system for confined space should be provided. Filter-type respirators should be used in open air. Airline respirators said to be used while working in toxic environment. During welding, fire can be caused due to sparking, bad condition of welding cable, loose connection at joints, improper return cable leading to inadequate current carrying capacity. Some of the precautions to be taken while welding are: keep away the combustible materials. Do not carry out welding near hot work in operational process plants. Obtain hot work permit and follow the instructions. Welding in closed containers should be carefully planned with adequate ventilation. Standard on confined space work applies. Oil or paint drum should never be welded with adequate ventilation. Standard on confined space work applies. Oil or paint drum should never be welded or gas cut. Thoroughly clean the container and purge it to remove combustible gases inside before doing any hot work. In a 40-gallon drum, a few ounces of oil is enough to form the explosive mixture, and this quantity may be present in the form of thin film.
In addition to the potential hazards we just discussed, welding also can adversely affect the health of people due to the fumes generated during the welding process.
Hazardous fumes generated during welding operation can damage airway, lungs, central nervous system, and cause even lung cancer. Types of pollutants depend upon the material being welded, the welding electrodes being used. If fumes concentration are found exceeding the occupational exposure limits, OEL, the following step should be taken. Change the process to non-hazardous or non-toxic. Improve the ventilation or fixed localized fume extraction. If above is not possible, use respiratory protection like mask, Constar type mask, compressed air respiratory mask.
It is now time for a quick check.
Correct. Correct.
Apart from welding, gas cutting is another activity for which gases are extensively used at Tata Steel. So let us take a look at the gas cutting process.
When acetylene gas is burned with oxygen, a high-temperature flame of about 3500 Celsius can be produced, and this heat is used for cutting metal by melting along the cutting line. Is there any risk of malfunctioning while gas cutting?
Yes, there are 3 ways in which it can happen.
Some of the hazards in gas cutting are fires, explosion, burn injury due to fire, hot material, etc. Injuries due to fall of cylinder or bursting of cylinder. Health hazards due to fumes.
This seems quite hazardous. Yes, it sure is.
Click each title on the screen to learn about it. Occurring due to incorrect pressure in both regulators. A. Torch nozzle obstructed. B. Nozzle held too close to the work. C. Blowpipe valves not opened enough to allow adequate gas flow. Completely shut both torch valves check regulator settings. Check nozzle. Relight. Ensure adequate gas flow. Backfire occurs on lighting up due to regulators not being set to correct pressure. Light applied before flow of gas mixture properly established. Nozzle obstructed or nozzle overheated. Close both blowpipe valves, oxygen first. Check cylinder pressure. Check and adjust regulator setting. Check torch. Relight when gas flow is properly established. Flashback is retrogression of the flame beyond the blowpipe body into the hose with possible subsequent explosion. Flashback is the most dangerous because of mixed gases in the hose. Usually, this mixing of the gases occurs when the hoses have been disconnected from regulators or blowpipes, or when new gas is being used for the first time. Usually, one of the hoses will burn and possibly be ignited. Preventive action. Ensure that all connections are tight. Use flashback arrestor fitted with the torch. Ensure cylinder valves are open and blowpipe valves are closed. Set regulators to the required pressure. Purge each hose separately for sufficient time to ensure only pure gas remains in the hoses. Close the valve for each gas as the exercise is completed. This exercise should be carried out only in the open or very well ventilated area. Click Next to continue.
It is now time to check how much you have learned about gas cutting.
Correct. Correct.
You are doing quite well today. Before we proceed further, it is important to take a look at the general requirements with regards to gas cutting and welding.
Following are some of the general requirements in gas cutting and welding. Work permit to be obtained in form number EHSMSM/works/446/4007 before start of gas cutting or welding by the authorized person of the department. After completion of job, the work permit shall return to the issuing department. If the gas cutting or welding job is to be carried out at a height of more than 2 meters from ground level or in a confined space, gaseous hazardous area or near an electrical installation, separate entry permit or work permit should be obtained from the authorized agency. Falling of spatters from height must be prevented. For this, a metal trowel should be used and spatters should be collected in a trough at the point of generation. Moist ceramic cloth may also be used wherever required. In case of problem in preventing all the splatters from falling down at the area below the site of hot work, the area has to be barricaded. No cylinders should be kept in the barricaded area. Proper covering of the knob, valves, etc. of the cylinders adjacent to the barricading must be ensured. All manual transformer-based welding machine should contain manufacturer's nameplate containing all technical specification as listed below at its top or front side. Source of manufacturer reference to Indian standard, manufacturer's type and serial number, minimum and maximum range of welding current, maximum continuous hand welding current, input current at rated output, input voltage, frequency and number of phases, open circuit voltages range, type of cooling, total weight, class of insulation, rated output of the transformer. Warning message worded as follows. Warning. Current in excess of the following are for intermittent use only. Portable transformer weighing more than 50 kilograms shall be provided with wheels made of cast iron or solid rubber. Transformer type welding machine should not be used at site after October 2009 as per circular number dated November 1st, 2006. Always use seamless tubing for connection to the cylinder. All cracked hoses are to be scrapped and removed from the site. The area should be examined for flammables before welding and cutting when the atmosphere is vulnerable to such hazards.
Now that you are clear about the general requirements, I have a question for you.
Incorrect. As gas cutting and welding are very correct. As gas cutting and welding are very hazardous, are there any preventive steps that we can take to minimize the risk?
Yes, at Tata Steel, we have clearly laid out steps for preventing such hazards. Take a look.
All gas cylinders should be kept with safety protective caps when not in use. It should be ensured that before starting the job, surrounding area of the work site should be made free of fire hazard. Employees engaged on welding, cutting and other hot jobs should be trained and capable to use fire equipment in case of any fire emergency. One number of 5 kilograms DCP extinguishers, 2 numbers dry sand filled buckets and 2 water filled bucket should be made available close to each area of welding, cutting and other hot job. Emergency telephone number should be made available and displayed at work site by concerned agencies. When practical objects to be welded, cut or heated shall be moved to a designated safe location, or if the objects to be welded, cut or heated cannot be readily moved, all movable fire hazards in the vicinity shall be taken to a safe place or otherwise protected. No welding, cutting or heating shall be done where the application of flammable paints or the presence of other flammable compounds or heavy dust concentrations create a hazard. Suitable fire extinguishing equipment shall be immediately available in the work area and shall be maintained in a state of readiness for instant use. Use of fuel gas. Nothing shall be placed on top of a fuel gas cylinder when in use, which may damage the safety device or interfere with the quick closing of the valve. Fuel gas shall not be used from cylinders through torches or other devices which are equipped with shut-off valves without reducing the pressure through a suitable regulator attached to the cylinder valve or manifold. Before a regulator is removed from a cylinder valve, the cylinder valve shall always be closed and the gas released from the regulator. If on opening a fuel gas cylinder, leak is detected around the valve stem, the valve shall be closed and gland nut to be tightened. If this action does not stop the leak, the use of the cylinder shall be discontinued and it shall be properly tagged and removed from the work area. If a leak should develop at a fuse plug or other safety device, the cylinder shall be removed from the work area. Oxygen cylinders in storage shall be separated from fuel gas cylinders or combustible materials, especially oil or grease, by a minimum distance of 3.0 meter. The name of the gas shall always be written prominently on manifolds. Proper ventilation and accessibility to the locality of fuel gas and the oxygen manifolds shall be ensured. Hoses of different use, like fuel gas, manifold and supply header connections, shall not be interchanged. When not in use, manifold and header hose connections shall be capped. Accessibility of valves shall be ensured at all times when in use. Fuel gas hose and oxygen hose shall be easily distinguishable from each other. The contrast should be made by different colors, red for LPG or DA, and black for oxygen. All gas hoses shall be inspected in each shift. Defective hoses shall be rejected and removed from site. Hose couplings shall be of the type that cannot be unlocked or disconnected by means of a straight pull without rotary motion. Gas hoses and cable should not be allowed to touch each other and must have a minimum distance of 250 mm between them, so that any heat or spark from the cable should not cause any fire in the gas hose. Clogged torch tip openings shall be cleaned with suitable cleaning wires, drills, or other devices designed for such purpose. Torches in use shall be inspected at the beginning of each working shift for leaking shutoff valve, hose couplings, and tip connections. Defective torches shall not be used and removed from site. Torches shall be lighted by friction lighters or other approved devices, and not by matches or from hot work. Only 3 pipe cutting torches shall be used. Oxygen and fuel gas pressure regulators, including their related gauges, shall be in proper working order while in use. Oxygen cylinders and fittings shall be kept away from oil or grease. Oxygen shall not be directed at oily surfaces, greasy clothes, or within a fuel oil or other storage tank or vessel. Only manual electrode holders which are specifically designed for arc welding and cutting and are capable of safely handling the maximum rated current required by the electrodes shall be used. Any current-carrying parts passing through the portion of the holder which the arc welder or cutting grips in the hand and the outer surfaces of the jaws of the holder shall be fully insulated against the maximum voltage encountered to ground. The electrode should not be dipped in water for cooling. An arc should not be allowed to strike on compressed gas cylinder or tanks or any enclosure, even if empty, which have contained combustible material without proper risk assessment. AC welding should not be done in damp or confined area. All arc welding and cutting cables shall be completely insulated, flexible type, capable of handling the maximum current requirements of the work in progress, taking into account the duty cycle under which the arc welder or cutter is working. When a cable other than the cable lead is worn enough to expose the bare conductors, the exposed portion shall be protected by means of rubber and friction tape or other equivalent insulation. All cable terminations should be properly made and shrouded. Open circuit voltage of welding set should not be more than 90 volts AC or DC. If the voltage is greater than 90 volts AC or DC, clearance from safety department is to be taken. Insulation resistance value of the welding machine should be more than 2 mega ohm with 500 volt mega. If the machine is down for continuously 2 weeks or more or got exposed to rain, then it should be megaed with 500 volt mega. For motor generated type welding set, the mega value shall be taken for both motor and generator. For transformer type welding sets, the mega value should be taken between primary and earth, primary and secondary and earth. However, transformer type welding machine should not be used at site after October 2009 as per Circular GMW/9146/06 dated November 1st, 2006. The machine should be switched on only when the mega value is more than 2 mega ohm. The welding machine is to be connected with separate circuit breaker or switch fuse unit, SFU. Pipelines containing gases or flammable liquids or conduits containing electrical circuits shall not be used as a ground return. Under any circumstances, no structure or pipeline shall be used as ground return. The frames of all arc welding and cutting machines shall be grounded either through a third wire in the cable containing the circuit conductor or through a separate wire which is grounded at the source of the current. Westguard safety device is to be connected between the welding set output and the cables connected to electrode holder and return clamp. This safety device is to be used while doing the welding job in the following areas to reduce the hazards of high voltage present in the welding electrodes. Confined spaces like inside vessels, storage tank, tunnels, etc. Wet or damp location. Hot and humid conditions. Working at heights provided the situation calls for wearing a safety belt. Westguard should be used in the metallic enclosure like oven machines in coke plant, EOT cranes and lifts, etc. When electrode holders are to be left unattended, the electrodes shall be removed and the holders shall be placed or protected that they cannot make electrical contact with employees or conducting objects. Hot electrode holders shall not be dipped in water. To do so may expose the arc welder or cutter to electric shock. The power supply of the equipment shall be disconnected when the machine is not in use. Where welding or cutting operations are being performed in areas where it is possible for molten slag to come in contact with other employees, those employees shall be protected from being burned by providing overhead protection, by barricading the impact area or other effective means. The rating of the earth leakage protective device shall not be more than 100 megaamperes with the fault clearing time less than 100 milliseconds. Appropriate protective clothing required for any welding operation will vary with the size, nature, and location of the work to be performed. Except when engaged in light work, all welders should wear flame-proof gauntlet gloves and apron. The welding gloves should be dry and free from holes and grease. Shirt collar, sleeves should be buttoned and cuffless trouser should be used while welding. Cotton or woolen clothing should be used while performing any gas cutting or welding. Outer clothing such as jumpers or overalls should be reasonably free from oil or grease. For heavy work, fire-resistant leggings, high boots, or other equivalent means should be used. In overhead work, a sheet metal screen in front of the worker's leg can provide further protection against sparks and molten metal in cutting operations. Shoulder covers made of leather or other suitable materials should be worn during overhead welding or cutting operations. Mechanical ventilation shall consist of either general mechanical ventilation systems or local exhaust systems. General mechanical ventilation shall be of sufficient capacity and so arranged as to produce the number of air changes necessary to maintain welding fumes and smokes within safe limits. Local exhaust ventilation shall consist of freely movable hoods intended to be placed by the welder or burner as close as practicable to the work. This system shall be of sufficient capacity and so arranged as to remove fumes and smoke at the source and keep the concentration of them in the breathing zone within safe limits. Either general mechanical or local exhaust ventilation meeting the requirements of mechanical ventilation stated above shall be provided whenever welding, cutting, or heating is performed in a confined space. Welding, cutting, or heating in any enclosed spaces involving the metals specified in this subsection shall be performed with either general mechanical or local exhaust ventilation meeting the requirements of mechanical ventilation stated earlier. Zinc bearing base or filler metals or metals coated with zinc bearing materials, cadmium bearing filler materials, chromium bearing metals or metals coated with chromium bearing materials. Welding, cutting, or heating in any enclosed spaces involving the metals specified in this subdivision shall be performed with local exhaust ventilation in accordance with the requirements of clause 5.5.1, or employees shall be protected by airline respirators. Metals containing lead, other than as an impurity or metals coated with lead-bearing materials, cadmium-bearing or cadmium-coated base metals, beryllium-coating base or filler metals. Because of its high toxicity, work involving beryllium shall be done with both local exhaust ventilation and airline respirators. Employees performing such operations in the open air shall be protected by filter-type respirators, except that employees performing such operations on beryllium-containing base or filler metals shall be protected by airline respirators. The chlorinated solvents shall be kept at least 200 feet unless shielded from the exposed arc, and surfaces prepared with chlorinated solvent shall be thoroughly dry before welding is permitted on such surfaces. When inert gas metal arc welding is being performed on stainless steel, the requirements clause 5.5.3b shall be met to protect against dangerous concentrations of nitrogen dioxide. Employees in the area not protected from the arc by screening shall be protected by filter lenses. Hand shields to protect the welder against flashes and radiant energy shall be used when either the helmet is lifted or the shield is removed. In enclosed spaces, all surfaces covered with toxic preservatives shall be stripped of all toxic coatings for a distance of at least 4 inches from the area of heat application, or the employees shall be protected by airline respirators. In the open air, employees shall be protected by a respirator.
Now that you're familiar with the preventive steps, let me ask you a question to check how much you remember.
Correct.
Another critical aspect you need to learn up today is about performing cutting or welding jobs near gas mains.
While performing cutting or welding job near gas main, use standard scaffolding. Check physically the pipe thickness. Check for presence of carbon monoxide percentage in the working area or vicinity of job. Gas cutting torch flame should not hit the pipe. No inflammable material should be present below the working area. And do not use gas pipe or gas pipe supporting structure for earthing the welding machine.
This was very insightful session. Is there any checklist that we can use to ensure we don't make any mistake while following these safety standards? Yes, we have a clearly defined checklist.
Click the icon on the screen to view the checklist for gas welding and cutting, and click Next to continue. Correct. 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 Incorrect. Correct. 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 Correct.